we'll talk about them again now just to help you remember. So the three plate boundaries or three plate margins are constructive, destructive and conservative. Constructive, destructive and conservative. This type is constructive, but we also call this a divergent border as well. So constructive or divergent, you can use either word, whichever helps you to remember. Okay, so this is basically just where the plates are moving apart. So constructive, moving apart, moving apart. Two plates moving apart. Constructive. When the two plates move apart, the magma, this liquid, hot, sticky rock, the magma escapes through the gap between the plates. So here are your two plates, they were together. As they move apart, here is a gap. And from this gap comes this current. This comes up between the gap and escapes. As it comes up between the gap, it meets this cold air here, or whichever it is, which depends on the type of plate. And it comes up, it meets this coldness here, and it turns into plate, a new tectonic plate. So constructive, remember, also called divergent boundary, is where two plates moving apart or diverging. The magma, liquid rock, is escaping through the gap between the plates. And this escaped magma, this magma that's escaped, cools and it forms crustal rocks. Remember the word crust, Earth's crust. And the crustal just comes from the same word, crust. So that are in the crust, basically. Okay, so the magma cools when it reaches the cold. So you've got under the water these mountains forming. But they don't have to be under the sea, it's just one example. Okay. One example of a constructive plate boundary is the Mid-Atlantic Ridge. And you can remember, if you think about the country, this Mid-Atlantic Ridge runs from the north to the south. And as the plates are moving apart, I mean, maybe in 1 million years or 5 million years, Iceland will be two different countries. Who knows? It's coming up. You have this volcano zone. That's why the volcano erupted in Iceland quite recently. And remember, I think I told you a little bit about what happened in Iceland. These volcanoes were erupting. This ash and magma was very, very hot, and these dust particles in the air. And basically where the weather is, the weather carried these particles across Europe depending on which direction the wind was blowing. And because of this, lots of aeroplanes were not able to fly. So ground control cancelled flights in Europe, because if these particles from the volcano went into the engines of the aeroplanes, they could cause fire. I thought it was like fans from spinning in the engine. So then you'd have loads of fires. That's the theory anyway, who knows. So basically volcanoes have quite an impact on us. So they're not just in textbooks, real life. Okay, so remember Iceland. Atlantic Ridge, middle of the Atlantic Ocean, and right in the middle of the Atlantic Ocean is Iceland. It sits right on top of this mid-Atlantic Ridge where the two plates are pulling apart. So the mid-Atlantic from the north to the south, north to south. The mid is what separates America and Africa, separates America from Africa and Europe. Okay, so you've got the American plate and you've got this African and European plate. So it's taking the countries apart. Perhaps 5 million years ago, the plates have moved apart. So it separated Africa and Europe from America. All right. Constructive plate boundaries often cause volcanic islands. Now remember that the word constructive comes from the word construct, which just means to build. And if you do this, it will help you to remember. Construct means to build, and what is built here? A new plate. From the magma coming up between the gap in the two plates, and it creates a new plate. A new plate is constructed or built. Alright? We call this type of plate boundary constructive because a new plate or crust is constructed from the escaped magma. Great, I hope you're still with me because we've got a little bit more. Now, type 2, destructive. Destructive. So, destructive plate boundary is also called a convergent plate boundary. Again, you can use either word. Some need to remember destructive, but the name convergent because convergence when two things come together. So you can use either word if you remember. Both of them are right. They're not wrong. Okay. So, we call this destructive because it means that one of the plates gets broken. One of the plates gets broken. Destructive. And this can be an oceanic and a continental convergence. So an oceanic plate and a continental plate coming together, or a continental plate and a continental plate coming together, or an oceanic and an oceanic convergence. So oceanic plates. In a destructive plate boundary, the plates are moved together. The one plate crumples, and when it crumples, you get fold mountains. So forward the piece of paper here, and it's kind of like crumples, and it makes these mountains here, foldings, which we'll talk about next lesson. When this happens, heat and pressure force the magma to the surface. It forces the magma to the surface, where it creates volcanoes. Okay? I remember this, a little bit gross, a little bit disgusting, but it helps me to remember. If you have a spot on your face, and underneath this pressure, this disgusting, yucky stuff builds up. What happens when you have a really big spot? It kind of explodes everywhere. And that's basically exactly what's happening in a destructive plate boundary, okay? So just think of it as a big exploding spot just going everywhere, okay? The pressure, like the crust kind of can't take anymore, and out comes this volcano, or this big spot. Remember that in the exam they will always ask you for an example of this. An example is the Andes Mountains. West coast of South America. And they are an example of a destructive boundary. Another example is the east coast of Japan. And we know that Japan has also been in the news a lot recently. So have a look on the internet, see what you can find out about that, because it plates that are coming together to form this destructive plate margin. One is the Nazca plate and the South American plate. Okay, Nazca plate and the South American plate. Now, there's another word you need to know here, which is called subduction. I already told you that sub means under. Okay, so subduction is basically when one of the plates goes under the other one when they collide. So it plunges. So you've got the two plates here. The heat subducts, goes underneath. The one that subducts starts to break off. Okay, because remember that it's meeting all this very, very hot magma underneath. So it comes together, subducts, and starts to break. Okay, broken. In this kind of plate margin, volcanoes form when the molten rock escapes to the surface. So the molten rock is escaping to the surface. You get volcanoes. You get earthquakes forming when the create friction. So as they come together, you get volcanoes and earthquakes with destructive plate margins. Volcanoes and earthquakes with destructive plate margins. Remember, that's very important. Okay. Now the third type of plate margin is conservative. And there are two ways in which this happens. The first one, I can show you here. Two ways, okay? And you'll have these notes later. When two plates are moving side by side. So remember, in a conservative plate boundary, the plates are always side by side. They're not colliding, but they're side by side. So in this case, you have two plates moving in opposite directions. opposite directions, or you have two plates which are moving at different speeds. So one is going quickly. I'm going to show you with my hands, it's a bit tricky. One is going slowly and one is going fast, but at the same time, okay, side by side. When they, just like when you rub your hands. Okay, guys, you're doing really, really well. So I hope you're still with me. Still good. Okay. Now, causes friction. Friction. Okay. Volcanoes are very rare. They hardly ever happen. So you can say they never happen, or they are extremely rare. But earthquakes, remember earth shaking, we have them in Georgia quite a bit. Earthquakes are common a lot. One example of this is the San Andreas fault. I told you a little bit about this on the Oceans Project and in class as well. The San Andreas is just the Spanish for Saint Andrew, and a fault just means a break. So San Andreas fault, San Andreas fault. San Andreas fault is an example of a conservative plate boundary. Okay, great. We call this type of boundary conservative because the crust is conserved. So the crust, the Earth's crust around the outside of the Earth, it's not subducted, it's not broken, it's conserved. Sometimes we call in England jam. Sometimes we call jams conserves because it's basically mixed with lots of sugar. And because of the sugar, it doesn't go bad, it doesn't go off, it's conserved. So you can think of words like this, like conservation. It just means to save, to keep the same. It doesn't get worse, so that's the English Georgian that will help you a little bit. Alright, so in this case, the crust is conserved, it's destroyed. There's no magma rising, so there's no new plates. But there's no subduction, either. And because of that, no volcanoes, because remember the magma's not coming up, so you have no volcano. Three main types of plate boundary, but there's also three primary ones, which we've already talked about, and there's a fourth one. And this is called a collision plate margin. So collision, two things bashing into each other, collide, okay? A collision plate margin happens when two plates of equal dense strength and they are the same heaviness or lightness, the same density, so they collide. Boof. Okay? In this case, both plates get squeezed upwards. You can see this if you see two cars that crash. If they are exactly and the same force. So when these two plates get squeezed upwards, they form what we call fold mountains. Remember, the word fold is just like folding, like you fold a book sometimes, or you fold paper. It's just when you turn fold mountains. And the mountains are called fold mountains because the Earth is kind of folded. It's kind of folded. The Himalayas were created in this way. The Himalayas is a good example of a collision plate boundary. Okay, they were created. Eurasian and the Indo-Australian plates collided. In this case, you get pressure at your big spots, but you also get friction, and this creates the earth tremblings, so earthquakes. And one final thing, it's probably best to know this yourself because it's quite hard to remember otherwise. It's very simple, but it's hard to remember. It's a lot of information. Where are the tectonic plates and their margins? Where are the plates and the margins? I have drawn you a map on your worksheet, a background in medicine and being trained to have very bad handwriting and very bad drawings. Not supposed to. It's my excuse. It's here, and I've coloured them so that you can remember. Okay, I've coloured them so you can remember the different plates and what they do. All right, so. Great work, guys. I'm stuck this far. 40 minutes is up to you to remember what we covered in class. And enjoy the rest of your weekend, and I'll see you next week. Okay? Bye. Bye-bye.